Oh, okay. But how would I know? I can just press it. Just speak to it. Hey, Sirisha, but can I hear her? I don't know if she can hear me.
I can hear you, Mary. And I've got
Great.
Renata as well.
Yeah. Hey, Mary.
Hey. Hello, Renat. Yeah. So here's the situation, right? We're a little bit we're too short time to kind of get this up, and then it's about time.
Okay.
And yeah, because the conference room here was occupied, we didn't get until late, so we're a little bit running around. And but thing is too, right now we are not able to get this voice thing to kind of get broadcasted to the room. In other words, then I would not be able to have both of you say something about Pittsburgh Jug, and I apologize for that. However, we would like to introduce you too, and we will just introduce you and telling the audience that you and your Jug, both of you and your Java users group is in the audience, and we want to thank you, if that's okay with you.
Yeah, that's totally fine. And we'll just make sure we share our info on this Chicago Jug page, and that should be good.
Yeah, that's right. If you have anything to share, yeah, just send it over, and then we can also share. That's right. Yeah, I will share then with our
Yeah.
Yeah.
Thank you so
Okay.
much.
Sounds good. Sounds good. No
Okay.
problem at all.
Thank you. Okay.
We will most
Thank you.
likely drop off the call then. Yeah.
Yes.
After the intros.
No problem.
Yeah.
Yeah, no problem. But yeah, just send me your information and I'll share with everybody. Thank you so
Okay.
much.
Thank you so much.
Thanks. Okay, cool. That's good. All right. Good. All resolved. Yeah, this is crazy. Yeah. Okay. Okay. And can you, this guy, I just have to, yeah, put in the lapel. Yeah.
Stuff around here?
No. Okay.
Good evening, everybody. My name is Steve. Usually people say, "Oh, David." I am, I work for Microsoft, and We're here. I love the crowd here. I used to be heavily involved in community events, and it excites me to see everybody coming out, giving up their Wednesday evening to come out and learn a little bit something about technology and interact with other technologists. So this excites me. It's the kind of thing that excites me. So thank you very much for coming. This would be an excellent time to silence your cell phones. Pause while they do so. One of the reasons that we have so many here is because there's so many people, so many organizers. We have the Chicago Java user group represented here. Eric? We have the GOTO conference. We have the Kotlin user group, Chicago Kotlin user group, and Senator, I forgot what organization you're in.
I'm with Spencer, but we are part of the mesh network.
Oh, they're kind of clandestine. Not for them anyway. And also the Pittsburgh Java user group. They're not physically here, but they are remotely, so they can hear me saying thank you to them. Who bought our food?
Pantry.
Oh, Pantry bought our food. Oh, another big hand for us. And the meal. Lots of food in the back. The rule is we can't leave. Nobody can leave until all. All right, we've got 3 speakers tonight. 2 of whom are excellent, and 1 of whom is me. And we're going to talk all about artificial intelligence, and we're going to lead off. Well, before we have our speakers, first of all, Meta from GOTO would like to say a few words about her organization and her conference.
Yeah, thank you. This big microphone.
I have a big microphone.
Thank you. As David said, my name is Mette. I'm not expecting you to say hi, Mette, because it's a very Danish name, so it's very difficult for Americans to pronounce it. So you have to excuse my accent because I am Danish and I live in Copenhagen. And I work for Trifork, and under Trifork we have GOTO conference. And I'm the conference producer for GOTO conference. The GOTO conference is going to come to Chicago in October. It's a 2-day conference about IT and tech. We also have a conference in Copenhagen and in Amsterdam. And we are collaborating with YAO in Australia, and they have 3 YAO conferences. So fairly big. So I want to do a little commercial for the GOTO conference, or I will say that we have a raffle later. I have some t-shirts that I'm wearing for you, some of you, and I also have books from Andy Greenberg. We had Andy Greenberg speaking at our conference in last October in Copenhagen. So he was so nice to sign some of the books. The books I have with me today is not signed, unfortunately, but maybe he will come to the conference in October, so you can come and get the book signed there if you want. And we are also going to raffle 2 tickets for the GOTO conference in October. It's going to be at Convene in Little Tower, so hopefully we will see some of the faces from here. Yeah, and we're also going to raffle something from, help me again?
Intelligent.
Yeah, intelligent licenses. Yeah.
Intelligent licenses. So
2.
Yeah, 2 of them. So in the first grade, I am standing over there with raffle tickets. So come by me and get a raffle ticket for you. And then in the end of the evening, we're gonna raffle them out shortly. Yeah. And then I just wanted to introduce Cedric from Spantry. And again, huge thank you for Spantry for supporting us with food and drinks.
Thank you for the honor of us doing so.
Will you have
Sure, yeah.
the very big mic?
Yes.
So thank you and welcome.
So there are a lot of great talks tonight, so I'm not going to say much. My name is Cedric. I'm a founder of the boutique consultancy here in Chicago called Spantry. We do a whole bunch of stuff, everything from React to Kubernetes to DynamoDB. And we've been a part of the meetup community for a super long time. And this is post-COVID, the most in-person faces I've seen at a meetup in Chicago while competing with a beautiful day outside. So thank you all for being here. It's going to be a great event. Thank you, GOTO, the amazing conference. I'm not kidding. It's the best. There's no one here from another conference, the best conference in Chicago, in my opinion. And yeah, we'll get started. So I think Barry, you're up first. All right.
Thank you. Thank you. Yeah, I actually also have this too. Can you hear me okay right now? Yeah, I think, yeah. If not, then I can use this one. But I actually have, sorry. I don't think I've turned on the thing because there are multiple of these. So. Okay, can you hear me okay? Yeah, no? Okay, maybe I'll use the other one. I'll switch, yeah. Maybe the other one works better. Okay. So confusing. Yeah. Okay, here we go. This one, right? Okay, I'll put it in. Sorry. This one, the clip doesn't, oh, it's kind of not working.
Yeah, I see. Hang on. Yeah, you're right.
Thank you.
Yeah,
Thank you.
probably the best.
Oh,
Oh, this is, right.
you
You know what? You want to use the handheld? Oh, you
Yeah,
have to
let
type
me-
though.
Oh, yeah. Well, I don't actually have to type. I don't.
Okay, here,
Okay,
turn
so
that
that's
off.
fine.
I think only one microphone could be active at a time. Tell me
Oh,
if this.
you're like all intrigued.
This.
Works, yeah. Okay. Hello. I guess this works, right? Everywhere here works. Thank you. Thanks for your patience with us. And yeah, here I am going to start. So this is my slide deck. So, okay. So enter the brave new world of Gen AI. This is the title of my talk. And I also mentioned a little bit, a short intro to vector DB search is what I'm going to talk about. I mean, as such, if I really want to go deep, it will take days to explain. So this is only a 25 minutes or so talk. So I'm going to be somewhat brief. There won't be much like examples, but I'll give you some links. And also I'm actually doing also on Twitch streaming. I try to get back into that, essentially a live coding stream too. So I'll be explaining more of those stuff on my stream too. So the talk too, just bear in mind, is a more high level conceptual kind of step through. So again, thank you so much for coming. So let me kind of introduce and give you an idea of the agenda for today. I'm just going to introduce myself quickly, also giving you a brief background of AI. Actually, let me ask you, how many of you are already working with AI in this room here? So a few, okay, that's cool. Or maybe AI or data science, that's included, machine learning too. Yeah, no. Okay, so I also assume because we have folks from Java users group and also Kotlin users group. So most of the time too, I think for those of us working with more like engineering development, we're maybe not as kind of responsive, so to speak, to AI stuff, right? And because AI tends to kind of, I guess more like Python is the de facto standard for it. So, but anyway, so this talk though, I'm hoping to kind of, pique your interest too, so then you would know, and whether we like it or not, it is coming, this whole wave of things that are coming. And in fact, I see Java being able to, get into the space being such a robust language too. I mean, why not, right? There are lots of things that can make use of the JVM to help us to do all the great stuff in there. So anyway, let me get back. So my agenda, I'll just kind of introduction and introduce to you a couple of the terminologies. And then I will also bring in some, introduction to vector database too. And then if there's time, I can do a quick demo. But I think if there's no time, then I'll just, just quickly show you a couple of vector database that you can work with. And then I'll share with you some resources. So first of all, who's Mary, right? So I'm a developer advocate. I'm experienced developer advocate. I was at IBM for 3.5 years too. And then most recently too, I was at DataStax. And I was doing mostly like initially doing more reactive programming, event-driven systems, and then into Gen AI for the past 4 months or so at my previous company. So, but now too, I'm actually going out and I like to become a bit more independent and doing more DevRel type of consultancy. So that's my thing. And I'm into Gen AI. And as you can see, I'm also a Java champion. I'm really passionate advocate. I feel like it should be shared, this kind of knowledge. It shouldn't be just for making money. I mean, even though, yeah, we need to make a living too, but there's so much in this kind of exciting field, software. We actually, we should find some joy in what we do is what I believe. So that's about me. And then I'll be sharing with you my contact information towards the end of this presentation too. So, okay, so I'm going to start now. So just a brief background of AI first, right? So when I also was told to at my previous company now, then they asked me to do Gen AI. And then I was like, okay, AI, that was also new for me. So I started doing some research trying to understand it. And I found out actually the documented case is that the earliest AI example came from 400 to 500 BC. And it's actually a steam-powered pigeons made by this Greek philosopher called Archytas. And that's claimed to be AI, although it's not really very artificial in a sense. It's actually a steam powered, so it's mechanically powered. So this kind of interesting. So then I kind of look into the most recent timeline, right, of artificial intelligence, the whole development kind of it. And we can kind of trace back to about 100 years ago, roughly, in the 20th century. As you can see, this is a graph or kind of timeline that I found, from this well, kind of small now on this here, the URL, but I'll be sharing with you this slide deck too. If you're interested, right, you can kind of take a look. It's roughly, in the 30s, there was golden age of science fiction. We're talking about AI. Alan Turing, who's actually, I admire him too for his kind of just amazing intellect, right? The father of modern computing. He actually, wrote about can machines think, and he started doing all this research, and then so on and so forth, and then essentially too, then you see the timeline. It's everything was actually doing to contribute to where we are today. And of course, now it's all Gen AI. However, the thing is that we have to remember AI essentially is all about automation in here. It's basically, human beings, we can basically delegate some of these work to robots in this case. But it doesn't mean we should get lazy, right? And the thing is, it's easy to say we can get lazy and just have robots do all the things. But here I am, Gen AI, there's just so much interesting things now. There's so much controversies too about, it's dangerous and everything. So it's kind of making us think too. But okay, so without getting into all these things, let's kind of start getting into, this AI, machine learning, Gen AI thing. So when we talk about AI, usually it's on the, the all-encompassing topic. It's basically, it's trying to mimic, how human beings' intelligence work, right? How we behave, all these things. And then you go inside this onion, the second layer is more about machine learning. So machine learning deals with, your training, dealing with like training and making the computer essentially learn from data, but then without really actively us trying to train it, so to speak, because we're trying to give it data and then have the machine figure it out, to train themselves based on the data. So essentially, too, this approach is mainly based on training a model from some data sets. But then that alone isn't enough. So we kind of get into deep learning. Then that's kind of like core of this onion diagram is deep learning, is the techniques to perform machine learning. And that would be inspired by how our brain thinks, getting into all of the neural networks, all of these. And that's what is kind of where the magic is, so to speak, in today's world, how the AI, the robot, the machine can think is really this deep learning neural network layer. So let's kind of take a look into this Gen AI era. As we know too, it came out in November 30th, ChatGPT came out and it was disruptive. It's disruptive because it has the potential to change the way how we consume information and content too. And it helps, or basically too, it generates new contents just based on prompts, right? So it's essentially too, Gen AI is a combination of using machine learning and deep learning to produce contents. And the thing is though, you may be asking, well, Gen AI, isn't that new? It is new, but the difference is that right before that was more predictive AI. Predictive AI is not like based on prompts so at all, and it's more like dealing with making business forecasts or weather forecasts, all of those things. And so a bit more like tied to you're making predictions based on some past data. And also too, you're making predictions on something like a forecast that has a limited time validity to that too. Like you can be weather forecast for the next month or business forecast for the next year, something like that. Whereas for Gen AI, instead, it deals with more creative content. As we all know, it can write essays for us. It can actually, design, fashion for us and write poems and write music. And as we can see too, OpenAI just came out with Sora. That's actually, generating video. That's really amazing too. So that's the kind of power of what Gen AI can do. And so just kind of stepping through really quick kind of history to it too. This whole Gen AI thing actually came, with the research, that's kind of dealing with like feed-forward neural networks about 20 years ago in 2003. And then in 2011, we see that Apple kind of brings AI and the natural language processing NLP assistance to the masses through the use of the iPhone Siri too. And then in 2013, and actually that is actually what is going to kind of shape to lead to where GenAI is basically with the word to vec. This vector way of essentially too is a technique of NLP, natural language processing, that uses neural networks to train and learn from word associations or large kind of corpora of text too. And that's the word to vec. That's kind of early form of this GenAI thing. And then in 2017, Google came out with this paper, a new simple network architecture called the transformer. You might have heard of this phrase that says attention is all you need. And that phrase too is basically the research they said is kind of comes from this transformer kind of a paper too, that essentially too is kind of what's leading to where we are today, the Gen AI. Okay, so now then let's also understand some of the players in the Gen AI era. So when we talk about Gen AI, there are generative models, as we are all familiar with now with GPT 3.5, that's, the ChatGPT, that's what it's kind of based on, right? And so as you can see there, these are like the models, right? And essentially OpenAI, we all know that it has, produced a lot of the models. And then there are also like Codex, which is a model that GitHub Copilot is based on for more coding type of model. And then there's also, these are just, again, just a small handful of examples like Midjourney, DALL-E, and Stable Diffusion. These are dealing with like text to image type of models. And actually here too, on the right top side is BERT. BERT is kind of the earlier form of LLM that comes out of Google too. And then there's also, of course, Llama that comes from Meta. And then Whisper is an audio type of model. And then Gemini is the most recent one that comes out that supports what they call like multimodal type of kind of needs. And so now those are example of models, and let's take a look too at some of the generative apps too. So first and foremost is ChatGPT. That's really has changed the way the whole thing operates, right? I mean, the whole world operating, everybody's ChatGPT now, and that's based on GPT 3.5. Okay, so as you can see, then I mentioned also about GitHub Copilot. And then there are also others like Bard and Bing AI, all of these from the Google, and then from Microsoft, and then Bing, right? And then there's also other like Notion, SEO, and Salesforce AI. All of these are generative apps that are dependent on these models that I just showed you earlier. So these are kind of like apps, but then of course there are tons of apps, and we see a lot of startup companies now doing a lot of different apps too. So that's really, this field is kind of growing. And then one thing I want to point out, that multimodal, like with Gemini. So that's what it's kind of a lot of also research kind of focusing on, is being able to do this like cross-modal kind of functionality, because as you can see, like Sora that came out of OpenAI is essentially you can do text and it comes out with video. So there's text to video type of kind of cross-modal kind of functionality. So we want to expand this modality, and you can actually, have write text and tell, Copilot to do the coding for you, for example. And of course, there's audio and video. So these are kind of essentially the 6 primary modes that you can be kind of dealing with, and you want to be able to generate, video based on some text input, or showing a video and have it write something, generate text for you. So you can see that's actually a growing area. It's also kind of will kind of bring us a lot of value, I guess, as in our society too. So. Okay, so how about then the players, right? The people players I want to bring up. There are like data scientists and computer vision engineers. They are more of the subject matter kind of experts. But then as far as us, right, I assume a lot of developers here, then we are probably the engineers for this, that you can be data engineers or AI engineers. Now, there are also prompt engineers too, that they're dealing mainly on Gen AI kind of a space too. And then of course, there are also ML ops too, which is essentially like DevOps, but extended to kind of service like machine learning type of needs as well. So these are just kind of just wanting to discuss, people, these are players in this whole new era. So now let me then get into the, discussion too of the different terminologies that are kind of popular now with ChatGPT, all these things. So first of all, GPT, it stands for Generative Pre-trained Transformer. So as such too, it means, it's something that does some transformation. So what it is that it takes simple prompts, right? So the difference now is that the prompts, no need to write, kind of speak like a computer program. You know how we used to write code and we would say, okay, this is your program, let's say a Java executable, you pass the flag or tell it what to do, all of these things. It's very strict rule. Whereas now with GPT is that you can just talk to your machine like you talk to another person. So that's very disruptive, and that's not able to do it because of NLP research, right? Natural language processing research too. So what it does is that it takes the prompts and it takes it as input, and then it does a lot of pattern matching to it. And so these are like what is called similarity searches to it. And then it answers questions for the prompts, and it produces contents like, an essay or design a dress, and write a poem, compose some music. So that's kind of GPT. And so it's just a kind of quick note is that GPT started showing up at around like 2018. And that's when Alec Redford's paper on GPT, generative pre-training, came up. It's only like 5 years ago on OpenAI's website. And it talks about how, generative language model can acquire knowledge and process dependencies, like unsupervised kind of training based on pre-training on some large diverse set of data. So then OpenAI then takes it further and developed like GPT-2 in a year later. And then so on and so forth. And then, of course, too, I mentioned about the image too, DALL-E or Midjourney, they came out in 2022. Essentially, to Stability AI developed Stable Diffusion. So that was like the first like text to image type of models that can handle text to image type of functionality. And then, of course, then 2022, that's when GPT 3.5 came out. And within like a week or so, or 5 days, and then it reached like 1 million people, right? People are all excited about ChatGPT. Okay, so now today's ChatGPT continues. All the big players are doing, many things now. Kind of like, the landscape is exciting, is changing all the time. Okay, so now let's kind of take a look into NLP, natural language processing. And what is that, right? It is an interdisciplinary subfield of linguistics of computer science. So the concern is to basically process like natural language data sets, data sets that are coming from huge corpora of text or speech corpora, for example. And then it uses like rule-based or probabilistic machine learning kind of techniques and approaches to kind of enables computer to learn, from the contents, and including, not just like, no longer, you be asking question, no longer does it just give you back exactly what it is. In fact, the context can be kind of not very definite too, so to speak, right? But then nice thing is it's actually able to kind of give you answers that's beyond, what you're asking for, giving you insights into something too. So, okay, so now then let's turn to LLMs, and essentially as developers, and that's what we work with, are the large language models. Large language models are a type of machine learning model, and it's also what is called like foundation type of model. But typically too, all of these LLMs are huge, contains a humongous amount of resources or data, set of data that takes, a lot of time to process, a lot of GPUs, and it requires all of these and requires like weeks and if not months of processing. And it performs like NLP tasks, and also generates and classifies text and answer questions and prompts just like a human being, analyze sentiments and chatbot conversations. All these are dependent on the LLMs. So LLMs are there to kind of do all the magic for you. So now, so now let's kind of take a look again in this conceptual description picture of where it sits, right? So as I kind of described earlier, there's AI on the outside, artificial intelligence, and then machine learning deal with all the supervised, and reinforcement learning. Then you get into the core of it, which is deep learning that's like dealing with ANN is artificial neural networks, and CNN is, I think, concurrent neural networks, and RNN is recurrent neural networks. They are different types of neural networks for different types of processing. They are catered for each one of them specifically. I think CNN is more for imaging, and RNN is for more, I think, more text-based kind of processing too. And then as you can see, GenAI is kind of like another subfield inside this deep learning, and then it deals with the GAN or VAE, they are more for image gen, and then transformers like LLMs are for more text type of transformation. And of course, there are also, audio and video type of transformation as well. So as you can see, this is where it stands, how is LLM kind of relate to the whole kind of field in here. So now then the question is, how can I work with LLMs? And just want to point out to you a couple of libraries too. And these are, I have to say, they're primarily Python interface, but for example, LangChain, maybe some of you have played with it. So LangChain is a popular, very popular, in fact, LLM. If you look into some ranking, I think for open source libraries, it's kind of the top one for LLM tooling too. And then there are also variations too, right, of LangChain. But anyway, so LangChain is one of them. It also comes in JavaScript and TypeScript as well too. And then Llama Index is another really popular one. But Llama Index, it uses some special like indexing to enable you to do searches like faster, for example. But it does essentially similar jobs as LangChain does too. And then there's also Palm from Google that works with this Vertex AI. And then Hugging Face, there's another one of these things that Hugging Face, you can all sign up for account there. And then you can, basically it has, think of it more like a GitHub repository, but for you to kind of get models and data sets and all of these things too. So it's, and you can play around, but of course, all these models are actually quite huge too. I try to play with it, but it takes a long time to kind of download. But anyway, so Hugging Face is something you can also register and get models with. And then here too, well, there are Java folks. So just wanted to point out, there's this tooling called, or library called JLlama. That's actually Java version of Llama. It's actually developed by DataStax, my previous company. The chief architect, he actually ported or developed that, and it's still in beta right now. So it's all open source if you want to play around with it. And then there's also another library called JVector too, and it's more lower level, and it's specific for doing vector search type of searches, and it's developed by the DataStax technical co-founder Jonathan Ellis, and JVector is used by Apache Cassandra right now if you use Apache Cassandra. So it enables like vector database and vector search, all these things too. So and also too, it makes use of Project Panama too. Just wanting to JVector that does is SIMD kind of processing, and so it enhanced kind of vector processing, and it uses like this specific well, okay, so I'll be talking a little bit about vector database, vector search, but essentially uses approximate nearest neighbor kind of algorithms, but they use the specific, like Microsoft actually developed this DiskN, is a special case of approximate neural networks, and that's what it uses to for JVector. So it enables vector search to be super fast too. So that's that. And then also there's LangChain 4J. This one is for Java too. It's not associated with LangChain, but it is a Java interface, which is nice, for Java developers like us. You can consider using that. It's a little behind, I guess, of the proper LangChain, but it actually works pretty good too if you wanted to use Java to interact with your LLMs. And then there's also Llama 2, which is actually a port from Llama C. So that's kind of some information for those of you who are, Java folks out here. And here too, do I still have time? I just quickly then kind of share with you maybe vector database and vector search quickly. So vector database, right? So what is it, right? So it's a purpose-built type of database that serves up like vector data type. So the reason why we want to use vector database for ChatGPT, if you think of it, right, we're dealing with these complex data that you have to essentially represent the data in a different dimension, so to speak. Now, the thing is that we all learned when we first started coding, or actually just us, right? We are just so used to single dimension data, scalar data form. Whereas for vector data type, think of it like it supports like multi-dimensional data. So these data too, essentially, right? If again, I'll be very quick kind of talking about it. Essentially too, let's say if you take a string, you need to essentially convert it to what is called vector embeddings. Vector embeddings are essentially numerical representation of, let's say, a string, any kind of data. And if you look inside the database, what it is actually arrays of floating point numbers. So they essentially, to each word will get converted, and it's based on some specification. So these days, we usually are using OpenAI. They have some specification that you can use that will guide you to essentially translate, your data into embeddings. So make sure that when you store them, you use that specific specification, then use the same when you go to query it. Just make sure about that too. So those are vector embeddings. So essentially too, you have to do that. So then it enables the algorithms to be able to do what is called like approximate nearest neighbor algorithms. So essentially too, if you're a math person, if you're familiar, right, with linear algebra, that's what it is. It's using a lot of the linear algebra type of matrix math, doing all of these dot product and all of these things. So just thought I kind of give this kind of information to you. Of course, if you use it, you don't have to worry about it. Usually it's the database that takes care of all of these things underneath the hood. So, okay, so that's just a kind of a quick thing. If we want to kind of describe a vector embedding, we usually use a two-dimensional way to describe it, right? So again, these are multi-dimensional data types. So they are not just a single value, but this value too, plus also what is called a direction. So on a map too, or kind of a two-dimensional kind of graph, then you can see that a vector one is located there, up there at that dot, but you kind of have that arrow that points to it like that. So then that's what it is that we want when we try to do a search, then essentially too, you have to, let's say V1 and V2 are what is stored there, and you have a string that comes in is V3. You want to look for the data that's closest to you, then there would be V2 in this case, kind of like that. So that's the idea. Okay, so this is another example, but giving you a bit more kind of concrete example of a cat and a dog in a house like that. But you can see if I'm searching for a cat, then a dog will come back first because it's animal, the same type, for example. So these are simplified examples to give you an idea of it. So here I won't kind of talk too much about it and getting all of these things, but essentially two vectors is a new type of data that's supported in a lot of established databases too. So I used to work for DataStax, so that's EstraDB that supports it, Apache, Cassandra, and there's also like Pinecone or Weaviate or PG Vector, like Postgres extension, for example, and Milvus. These are kind of like a quite popular type of vector database. Okay, so these are just talking about what a vector embedding is being used for. They are good for using it for similarity searches and clustering recommendations. Like if you think of your product recommendations, you can actually think of using vector embeddings too. It helps, because it calculates how close, certain things are to what you're searching for, and it will give you, all of the results as ranked by how close they are to what you're searching for. Anomaly detection, diversity measurement, classifications, all these are kind of typical usages of vector embeddings. Okay, so just a word too about traditional database. You can use kind of still the relational database, but I don't think they are built, specifically for you to handle vector kind of data type too. So you may not want to do that because it would take a long time to process, and also you have to do all the conversion and everything. So. Okay, so this is just a quick diagram to just describe to like how it sits, a vector database sits in there. And essentially, without going into all the details, but you can see too, it sits in the middle and serves up all the embeddings and kind of store the embeddings for you. The thing is that you don't necessarily have to use vector, a vector database, but the thing is, then you have to maybe do things in memory, all of these. And as you know, LLMs, large language models, it doesn't remember things, right? You search for something, you ask it again, it doesn't remember. So that's why you may want to consider using some sort of database to help you keep the state information between different queries. So that's that. Okay, so I think I may be getting kind of too long now because it's I've talked for almost, I think, 30 minutes. So I will skip the quick demo part, but just wanting to point out to you, again, GenAI, just want to quickly say, what's the benefits? I think we all know, I kind of like to say, you ask and you shall receive. You always receive some answers, but make sure you ask wisely too, right? And the work is being done for you instead of you having had to go through some of the, repeatable or mundane kind of things. That's good. But the challenges are plenty. And it's basically to what is called hallucinations. As you know, too, if your model doesn't have the answers for you, if it's not built correctly, it can come back to you with wrong answers. And I like to kind of point this to you. I was playing around with JLlama, right? When I was at my previous company, and I was using GPT-2 because it's smaller. I downloaded the GPT-2 model, a mid-size, so smaller. Then I was asking it about stuff, right? About like, can you tell me who this guitarist is? It didn't have the answer. And it came back with swearing. And I was like, oh my God. Swearing at me. I said, wait a minute, this is getting too much. But of course, that was an older model. I think the newer models can handle things better now. So Yeah, actually, I want to kind of point out another fun things too. I was also kind of searching on the internet, some TV journalist who is in a technical investigative reporting, and he was playing around with, in fact, with Bard, so the Microsoft one, and and he was asking about the bot about some things, and the bot then was saying that, are you in love with me? Something like that, really weird. That's turning creepy. And then he said, no, I have my wife and I'm not interested in you. And then I guess the bot came back and said, I think you are in love with me or something. It can get really crazy too, is what I'm trying to say. So it's kind of funny. But anyway, so that's hallucinations. And then there are also like ethical concerns, right? Potential misuse. So even you could be using it without knowing some implications. So please be careful because there's no regulations right now. And then also another note I want to point out is that LLMs are great, doing a lot of things, but it's not all almighty because it's a static, huge chunk of data that's being trained from some old times. For example, ChatGPT 3.5, right? The fancy one that came out, but they train data only up to 2021. So what to do, like 22 and 23, it doesn't have the data. So you actually, there's a technique called RAG, right? You might have heard of retrieval augmented generation pattern. That's what, it's an architectural pattern that essentially helps you to feed in data that's kind of outside of the LLM. So then you can kind of fill in, what's missing too. So there's a RAG pattern for LLMs. Yeah. So essentially that's that. So that those are kind of known kind of shortcomings of this Gen AI thing. So resources, just wanted to share with you. If you are interested, this is my slide deck in here. And I will share with you too. Basically, I think on our website or if you're on my Discord or on our CJUG Discord too. Yeah. So, and if you miss, yeah, like I said, I will share with you. Yeah, so, okay. And then also another thing is that I mentioned that I'm doing a Twitch stream. So this is my Twitch, and I also stream it to my YouTube channel too. If you want to follow me on there, I'm trying to do it Wednesday, Thursday, Friday, or Friday afternoon. One of these afternoons, I'll do different things. I've actually done the JLlama too, and I do plan to do something with LangChain at some point as well. So yeah, okay. And with that, whoops. Oh wait, sorry. Here. And with that, sorry, I clicked the wrong thing. Okay, so just want to say thank you. I think I go over maybe 2 minutes. Yeah, so thank you very much. Jen. Okay, so you take my computer. Oh yeah, that's it. Okay. Let me. Oh, you plug it. Okay. And so in this case, I should just unplug this. Oh, okay. So this one I'll keep it there. And this is the microphone.
Okay, thanks.
Okay. And you want to swap out, right? Yep. Okay. I didn't go over too much, right? Okay.
It was good stuff.
Oh yeah, that's right. The one that I was using.
What's that?
Because there was another one that did.
Mary, thank you so much. That was a tough act to follow. That on? Okay. It's green. Not cool. Maybe the volume. The volume switch. Test. Test. Check. 2, 1, 2, 3. How many sound engineers does it take to change a light bulb? Look at that. All right. I'm thinking the guitar player that cussed at me was probably a punk rock guitar player. That's my guess. It was Sid Vicious, probably. All right. I'm back. My name is David. I'm going to talk more about artificial intelligence. Mary spoke about a few things that I'll maybe dive into a little bit more detail, but not a whole lot because I only have 30 minutes, so I better get started. But first, I'll talk about me. This is me. I work for Microsoft. I'm what's called a partner solution architect. I help our partners to build applications and deploy them to our cloud, Azure cloud. That's really what I'm going to talk about is the artificial intelligence tools that are available within Microsoft Azure. And there are a lot of them. I should talk about me a little bit here. There's my blog. It's just my name everywhere. On social media, you can find me there. And I hope you subscribe to my shows. I got 2 shows there, one at technologyatfriends.com and one at aka.ms/gcast that I put out every week or 2. All right. We are in the middle of another revolution. There have been a lot of revolutions, in the 80s, we had the PC revolution and the internet came along and exploded, and this smartphone revolution came along. The invention of the iPhone really made that take off. Cloud computing about 20 some years ago revolutionized the way that we're deploying things. And then right now we have artificial intelligence. And it's funny about each one of these things, they all existed long before they became a revolution. There were smartphones long before the iPhone came out, but somehow that was a watershed moment. The marketing genius of Steve Jobs holding this thing up on stage just captured people's imagination. Suddenly everybody had to have one. And now, I don't even have a landline anymore. And same with the internet was around since the 60s. Well, but it was really in the 90s or different categories of it. It's been around for at least 50 years, but recently there's been just all kinds, last year and a half, really. I think really since ChatGPT. ChatGPT really captured the public's imagination. And ChatGPT was created by a company called OpenAI, and Microsoft has partnered with OpenAI. We didn't acquire them. We've invested in them, and they're deploying their models onto Azure, and then we're using a lot of the technology in our products, some of which I'm going to show you today. They're all about generative AI. So that's kind of what I want to talk about. And Mary already told you this, the idea of artificial intelligence, just the idea that we're going to try to simulate human intelligence through the computer. We're not quite there yet, but we do have some things that humans do pretty well, like learning without explicitly programming, learning from data, doing some reasoning in a human-like way, and then also learning after the fact, self-correcting, getting new data and correcting. So if we say, hey, you know what, the name of that guitarist is not a cuss word, it's actually Johnny Rotten, then it can learn from that and give the correct answer next time. And this is the idea behind artificial intelligence. Generative AI, I think Mary covered this already, but it's the idea that we're going to create new content. We're going to look at existing content, whether that's words or music or pictures, and we're going to be able to generate new original content. Or I say the computer will be able to generate that based on that, because it'll learn how English is constructed or other human readable languages are constructed. And it'll understand that. Does it using large language models by just scouring through just massive amounts of text or images or audio and just learning what the patterns are in there and what a legitimate sentence sounds like and how it's structured. So this takes huge amounts of data to do this. That's the other reason why I think artificial intelligence is starting to explode right now, is because of cloud computing. Because now if you want to build a large language model, you can rent space in one of the big clouds. And you don't have to have a huge data center in your basement to do this. The cloud has kind of democratized a lot of computer science, a lot of really high compute power that you can sit in your basement and rent that and create these things yourself. These are just some of the tools that are available inside of Azure. I'll go through them really quickly. I'm not going to dive into too many of them, but I've got a couple of demos at the end. I've got to set my timer. Let's just say I'm starting now. So Azure OpenAI, this is the tool that is built on top of the ChatGPT, and it does allows you to create things like chatbots that understand the human readable text and can output human readable text and answer those questions. And Azure AI search. I'm going to talk a little bit about that later on, which we'll do intelligence searching rather than just keyword searching. Azure AI service, these have been around a long time. They used to be called cognitive services. And these are just APIs you can call, just a single web service call that'll return like the images or the tags in a picture, describe a picture, or do optical character recognition. They're really, I love these things. They're so simple to use. And then a couple of co-pilots. This is probably my favorite part technology is these co-pilots that just bring the power of artificial intelligence into your daily work. So if you can have help writing a letter or sending an email or writing your code in maybe a language that you're not familiar with, or even if you are, just to saving the time for that. Just summarizing a large document or a bunch of documents, or getting caught up on a meeting that you missed without having to read or sit through the entire recording. Things like that. Just amazing stuff that's available in these co-pilots. Whisper is doing audio transcriptions, taking audio and turning it into text automatically. Microsoft Designer, this is Microsoft's implementation of DALL-E. DALL-E is, of course, image generation. It's very popular right now, and we have a service hosted in Azure that does that. And then some user interfaces like Copilot Studio and Azure OpenAI Studio, which allow you to do this without writing a lot of code. All right, so there's a lot of things, and I'm certainly not going to cover all of them in here, but I would start with search, because search is a really interesting thing. This is another thing that Mary did bring up, is that the AI has enhanced the way that we're doing search. You know, the traditional way of doing search is keyword search. You know, you type in kittens, and of course, the internet is full of kittens, because that's what it's made of. And it brings up a bunch of links with articles on kittens and pictures of kittens, and that's great. It's just doing a keyword search. It understands it's indexed the rest of the internet, and it knows where to find articles and pictures and videos about kittens. That's great, but what's better is what ChatGPT brought along, and now it's incorporated into Bing. If you go to the Bing page, you can use Bing Copilot and ask your questions, not just about kittens, but intelligent questions. And it will understand that, you know, suggest if I wanted to, like this presentation I'm doing now, I could have got the outline from typing into Bing Copilot. Suggest for me an outline for a presentation on artificial intelligence, and it could create that for me. I could even tell it, suggest an article or write an article for me. I could do that. That seems unethical to me to have Bing Copilot or ChatGPT write a full article for me and for me to take credit for it. But creating an outline seems reasonable. I could certainly start with that. And this is really powerful. It understood that sentence, was able to go out and find in its model, in its large language model, you know, first of all, what you're looking for, and then generate a reasonable outline in English. And do it many other languages as well. And then Mary did mention the RAG pattern retrieval augmented generation. And this idea is that you will not just take the large language model as it exists. Mary pointed out that the GPT 3.5, I think, is the one. It's a couple years old. It's 2 or 3 years old. So if you ask it who won the Super Bowl in 2024, it will not know. But I think more relevant to a lot of folks in this room is if you ask it, what are my human resources? What's our vacation policy? It certainly will not know that because it's behind your firewall. It's not indexed by these large language models. So it doesn't know anything about the stuff that's inside of your organization, the private information, but you can use the RAG pattern to enhance what's already in the large language model and build a workflow similar to this, where you say, all right, I've got all the stuff that's out in GPT or whatever large language model you want to use. There's a lot of them out there. And I'm going to use some kind of orchestrator to enhance that by also adding the indexing the information that's inside of my organization or information that's since 2021, or maybe I'll take that information and I'll apply some Azure AI services to do image recognition or sentiment analysis or things like that. All sorts of things that you can do to orchestrate that. And this orchestrator keeps track of the context. So if you ask it a question and then you ask a follow-up question, it understands that, oh, I just asked about my vacation benefits, and the follow-up question just says, can I take those in the same year? It'll understand that, you know, I'm talking about vacation because that was the last question I was asking. Things like that. So this RAG pattern is really, really powerful for your organization. If you wanted to take the power of AI and enhance what you're doing. All right, and then there's hybrid searches as well, where often the output of these things is, yeah, we've got some human readable text that will describe what the answer to your questions. Here is your vacation policy, and it is you get 3 weeks a year, and then after 4 years you get 4 weeks a year, and here are the links to it. So it's a combination. You can do this as a combination of both a keyword search and this large language model search, which is really helpful because sometimes using LLMs, using something like GPT models isn't appropriate. Sometimes keyword searches are better. They're just more appropriate. If I want to know, about kittens, just tell me about kittens. I just want some links about it. And this is, I have this slide in here because people always ask this question, what happens? Oh yeah, you're going to index my internal data. Why should I trust you? And you can trust me because it's on the slide right here. Where if you're using the tools inside of Azure, then the data that you index internally is not used as part of our large language model. So OpenAI has gone out, indexed the internet and understood it's built its language model on text that's publicly available on the internet. And if you add to that, if you enhance your own model with your own internal text, using the enterprise tools, then those are not contributed back into the large language model. That's protection that you have right there. There's also encryption and at rest encryption and transit, all sorts of things as well. But I think the big one that people always ask about is this one. I don't want my data going out and maybe becoming potentially an answer to somebody else's question that isn't part of my organization. All right, I won't go into a lot of detail here, but there are a lot of ethical considerations about using AI. And this is these are the 6 pillars that Microsoft has published as part of their responsible AI. Ideas like privacy and security is certainly one of them. We don't want to, if we're indexing information about personally identifiable information, we don't want that to be published to the wrong person. There's a lot of the text that's generated. There's a potential for it to be either hostile to certain groups, or maybe just ignoring certain groups, or even the text for images or image recognition. There's, models. There's been problems with things like models that were trained to recognize human faces, and for certain skin tones, it didn't work because it wasn't trained on a wide range of faces, and that's a problem because we live in a society where there's lots of different skin tones, and so we need to be able to have transparency, fairness. I won't drill into this here, but there is a document that I think it's in the notes of this that I can share. We got that. All right, that's my slides, except for some demos. Let me show you some demos here. Let's see. All right, this first one is just a cool demo that I found on the web. It was created by somebody at Microsoft. It's a few years ago. All the documents related to the John F. Kennedy assassination were publicly released. The U.S. government decided to release them to the public, make them available, and somebody at Microsoft actually created an open source project, indexed all those documents, and you can search them right here. So if you want to search for Oswald, Lee Harvey Oswald is the man who, unless you're a conspiracy theorist, he's the one that actually killed John F. Kennedy. And I can search for him, and you see that it'll bring back a bunch of links with his name. He's mentioned a lot in these documents, but it's not just text. You can see that it's typewritten text, it's handwritten text, it's a picture of Lee Harvey Oswald. There's type or handwritten text inside of a typed document. All sorts of information here that was able to figure out that Oswald was a part of this document, an important part of this document. So even though that picture is not even mentioned, it just recognized his face. And then even more than that is, Barry mentioned the vector databases that can figure out, what entities in this model are related to each other. Well, that's happening. This is stored in a vector database, and there's a visual representation of this right here. So these are the things that are related directly to Oswald. The commission is related to, and things that are peripherally related to him. Helms, that Jesse Helms, maybe, I don't know, not directly related, but tangentially related. So if I go on to Sylvia Duran is a woman that Oswald met with in Mexico a few weeks before the assassination, and there's some speculation as to whether or not they had a relationship. But so they're mentioned a lot together in these documents. You can see these are documents that mention both Duran and Oswald. So just kind of cool things that you can do. This is all open source. On my slide deck, I have a link to all the source code on here. So I just thought it was pretty cool. I'll show a couple more things. Microsoft Designer. This is if I go to, I think it's Designer, DEZI, designer.microsoft.com. You can come in here. You have to, most of these tools you have to subscribe to. Some of them are free, but you have to say, I want to be a part of this, and then wait a day, and then they'll come back and say, okay, you're good, you're good to go. But here's some examples of it right here. This one, somebody typed in an ornate sitting room with floral wallpaper and single gold frame painting on the wall with a focus on a single green velvet armchair. And there's a picture right there. But you don't take my word for it. You can come down here and say, there's ticker creators and removing background, but just image creator right here. I'll put in something like, it's image one. How about an astronaut eating Chicago style hot dogs in a desert? How about that? And it'll go out. It'll go out. And it's indexed a bunch of pictures. It knows what an astronaut looks like, and hopefully it'll come up with some clever. And you could actually, maybe I want to do it in the style of Van Gogh. Maybe that would be more interesting. I don't want to. You can see it takes some time to do this, but this would be a good thing. Like maybe you're building some advertising, or maybe just images for your presentation right here. There we go. So there's the astronaut eating it. So it looks inclusive. It's a female astronaut. I like it. I get a lot. Not Chicago style though. Say it is calling that out. And this also, this lady has 3 arms. Did you notice that? So yeah, and those are the hallucinations about her. It doesn't quite understand that. I want to say in the style of Van Gogh. I just want to change the way that it looked a little bit. Actually, if I did the same prompt again, it would come with different languages. So it's not deterministic. It's stained glass. That'd be kind of cool. Stained glass and mastermind. You get lost in this for hours. It can be productive, but not really. Yeah, it just has a starry night behind it. Pretty good. All right, let me show another thing here. Where am I here? Come on. Option F5. Oh, this is a good time for a quick review. Yes. This is one of the co-pilots. So I really love these co-pilots that make my life more productive. I'll start with the 365 co-pilot. 365 is, we call it Microsoft Office, and I can go into Word, for example, and create a new document right here. And this thing pops up. If it didn't pop up, there's a button up here that says Copilot. You do have to subscribe to it. I think it's like $20 a month, something like that. But I can say, write an article about Gen AI tools in Azure. Click, and it'll generate an article. I give it to my boss and say, I'm done, boss. I'm going home for the day. Anyway, I think, as I said, I think that's kind of unethical, but it can also summarize documents. You give it a long legal document, say, tell me about this in 3 paragraphs left. That's really nice. It's going on. This is reasonable. I don't know. I haven't read this one yet, and if I ran it again, it'd probably come up with a different article. But it looks like maybe I had a hiccup on the internet. But anyway, but I can't. I'll go back to Copilot, and I'll say, let's see if that whatever the error was is going to keep me from this. How about make it 2 paragraphs? Let's see if that works. Usually I get a long article. I tell it to make it shorter. The other thing I can do is I can tell it things like, the target audience. The target audience is junior high school students. It'll come up with a completely different style. I find that really useful. If it comes up with something where the target audience is for an academic publication, that might be really interesting. Come on, finishing up. Yeah, I have a question right over here. the question is, are these, what is back end of these tools? And they are powered by OpenAI's tools, like these GPT models that are enhanced by some other technology that Microsoft has developed. So they're developed in conjunction with the OpenAI folks. We're working together. So this made it longer. So it looks like it added another paragraph off to the right that I could then copy and paste in here. That wasn't what I was expecting. I thought I would do it right in the middle here, but I certainly can do that. All right. And let me close that here. Let's see. I'll show you in Teams. I don't know how many over time, because I want to get to the coding stuff. I got about 17 minutes up in here. All right. Let's see. Oh, so if I'm in Teams, this is kind of nice. One thing that it can do is if I create, if I'm in a Teams meeting, for years, Teams has had the ability to summarize a meeting. You know, if you miss the meeting, it could give you a summary of it. It's getting better and better. But I just created a Meet Now thing. I'm gonna close that and unmute my speakers. And this only works if I have a transcription running. If I start the transcription and do this, and then I can. But soft, what light through yonder window breaks? It is the east, and Juliet is the sun. Arise, fair sun, and kill the envious moon. The sun was shining on the sea, shining with all her might. She did her best to make the billows smooth and bright. So I'll just have some text in here. And in the middle of the meeting, maybe I come in and I click Copilot here. Let's say maybe I joined it late, and I say, I just joined. What did I miss? Just simple feature like that I find really, really helpful. Come in half an hour into a meeting, just catch me up in a very short thing. I don't have to read the whole thing, and it'll look through the transcript. So this is, come on, read. There we go. We've had meetings so far. It not only recognized this, but it recognized what I was quoting from, and then what was that about the sun? I mentioned, you know, I was talking to somebody else and I heard the word sun. That's important. I'm the sun department, and it explains that part, that specific part. It goes back through it. A simple example here is only like 60 seconds of text, but you can imagine an hour into a meeting, oh man, they said something about that department. I could do it. I think it's a really cool thing. At the end of it, even by default, if you have a transcription, it'll just say, do you want a summary? You say yes. In fact, 10 minutes before the end, it'll start doing that. All right, that's really cool. All right, now we got a lot of developers in this. So I really want to get to the GitHub Copilot. And I've got this is a Visual Studio Code. It has the GitHub Copilot extension. This is a paid service, by the way. The individual ones I think are $10 a month, and then the enterprise ones are $20 a month, which give you some extra security features. But this is I just got a blank PowerShell script open right here, and if I just start writing code, sometimes it just automatically pops up. But sometimes I have to hit Control Enter. I haven't figured out what the difference is. Bring me down. Let's try this again. Oh, there we go. So I just pressed enter that time, and it said, "Oh, $Jen equals 1." That's what I typed. It's suggesting, maybe you want $Feb equals 2. Maybe you want $March equals 3, and it can just start suggesting these things. And why don't I just go back, Control Enter, and it'll load a suggestion. Now you can probably guess what it's going to do is all these things right here, and then I can just say that's a good one. I'll just accept that suggestion. There's a second suggestion as well to figure this all out, or I can do something like just adding in a comment. Like here, I'll just pound is in PowerShell, right? That's a common thing. I think it is. Create a hash table with months as numbers. And here's do Control Enter. Oh, Control Enter. There we go. And it'll come up with a suggestion here. Wait a second here. What is numbers and names? That's not what I said. Did I? With a number assigned to each month. How about that? There we go. That's what I was looking for. Something like that. Really cool. It just wrote that code for me. And even if I knew how to write that code, maybe I'm new to PowerShell. I'm not really familiar with how to create a hash table, but maybe it's just a lot of code to write. And I just didn't want to be bothered typing. Let it do the grunt work for me. They even suggested maybe you want the same thing with the day of the week. If I hit tab right here, then it can do that as well, which is kind of cool. Hit tab to accept it. But more practical is maybe log into Azure. What's the PowerShell way of doing that? Well, there's a couple ways to do that. But there's one right there. Connect to Azure and create a new resource group. If it, how about this? Named my RG1 in East US region. Things like this. Like this. And it's just, I'll create a virtual network named that. Just hitting tab, tab, tab. So it can start to understand some of the things that you can do with this. This is really powerful. One, if I'm working with a language that I'm not really familiar with, I'm working with a technology, maybe I'm connecting to some database that I don't know about, or hitting an API that I'm not really that familiar with, then it can suggest these things for me. It's worth pointing out that you still have to review this. It's not 100% right. It often, I shouldn't say often, it sometimes gives the wrong answer. And that's why it is called co-pilot. You are the pilot. There's no pretension that this is going to get you. This gets you like 80% of the way there, which is awesome, but you're still responsible for everything you write. Just like you're responsible if you say, summarize, create me a summary of a presentation on OpenAI. It may hallucinate, it may give you some wrong information. You still have to verify that's correct. All right, some other cool stuff here I want to show you is I've got I won't say that. Here's a C# project right here. So Java, a lot of Java developers, you should be able to read C#, and Kotlin developers are the smartest of all, so you should be able to read anything. And so here, let's see, I've got, this is an unfinished class right here, an unfinished method here, get order, and just calls an API, client.getAsync order/ID. So it's going to return this response. It's an HTTP call. It's going to return a response, and it's an HTTP response, so it should have like a 200 means it's okay, or if it's a 400 that's bad, and you want to get the message out of the body of that response. And so if I say handle the response if the status code is 200. How about that? That sounds pretty good. Actually, what I want to do is, how about if the status code is not 200? So if it's not 200, there's probably a problem. So if it's not okay, then throw an exception. That seems pretty reasonable right here. But maybe that's not the way that I code. Maybe my organization, I do something a little bit different. And this is where, this is really cool. Check this out. This is where it really shines. I have this other class that I opened up, pet proxy, do something really similar, just calls a different API, and it's completed. And this is how I like to handle if the status code is not 200. I want to get an error message, write that error message to the console, and then log it. And so I'm going to leave this open. As long as it's open, Copilot is smart enough to understand that this is the way I like to do things. So now, save it. Not HTTP, okay, right here. See it? It understood the way that I do things. It understood things like, I like to have this console write line. I like to have an error message. I like to, if I had naming conventions there, it would use that. So this is really powerful. I think if you've got ways of doing things, give it hints, give it some hints. So there's a couple things you can do. One is to open things up that are like, if you're calling a class, maybe having that class open, having the source code of that class open will be helpful because sometimes the IntelliSense isn't enough. But if you've got some conventions that you use, it understands that. The other thing that's really good is asking your question explicitly. The more explicit you can be, that's true of all of these tools, that if you give it, you tell it Don't just say handle the response. Say handle the response if it's not okay. And the more information you give in the prompt, the better a job it is going to be. I think I've been up here about 30 minutes. I think I'm about 28 minutes. Give me 2 more minutes. Let's see. Where's my slides? There we go. Let's see. Copilot showed that. OpenAI, I don't think I have time for that. I think I am done. Thank you so much. I'll take just like 2 questions if you have them before the next speaker. There's a question in the back. Go ahead.
You mentioned that keyword search is sometimes better.
Yeah.
Is it because you want more of a deterministic output?
Yeah, it's more just context of it. Just sometimes you just have a word you just want to find. Like if you just want to learn about kittens.
Repeat the question.
Oh, the question was and under what circumstances is keyword search better? And I think there's no real deterministic answer to that question, but just think about the context of it. If what I'm doing in Bing or Google, if I'm Googling with Bing or Binging with Google, if that the way I've been doing all along gives me the right answer, that's enough. Most of the time, actually, that's what I use when I search. I don't go into ChatGPT or Bing Copilot. I just want to search for information on Martin Luther King. I'm not something specific about him. I just want general information. In that case, just keyword search would probably be better. But if I wanted to know what were King's thoughts on some specific topic, then on nonviolent protests or violent protests, that would be good. The subtlety of that would be better for a large language model. One more question.
Some of the features you were showing at the end, is there an option to do fine tuning or anything like that, like some of the base models?
The question was on the, you haven't heard the question actually. So you're talking about the GitHub Copilot stuff? I don't know about the image search. I think it might be a preview. I'm not sure if it's released. It's brand new for the 365 Copilot. Yes, you can bring your own documents into that. There was I'm not sure I can bring it up here, but is it still open? If it's still open, but you can actually bring up documents of your own to enhance it that way. I don't know what's under the hood. I really haven't played with that very much. So he's asking if we're using RAG under this. Probably the RAG is just a pattern. So probably yes, it is using RAG in some way, but I couldn't tell you what the implementation is. And I really haven't played with it that much. But I noticed that when this pops up, there's this reference a file button right here. And it brings up a list of recently used files. And I'm not sure why it only has 3 and not the option to get more. But there is the ability to bring in more information in here. All right, I'll be available for more questions, but we're going to take a break. How long is our break going to be? Half hour. We'll take it 10 minutes and we're serious. 10 minutes. Oh, what's the price? 2 IntelliJ licensed T-shirts and books. And 2 tickets to a conference. Retail value of like over $1,000, right? Over 1,000, I think, right? Yeah. So fabulous prizes. Grab a ticket. We'll start up in 10 minutes.
Excuse me. Okay, everyone can make your way back to your seats, please. You want to get started again in a few minutes? There is one more talk. Oh yeah, well I don't have. We're not doing audio through the computer, so I can't do that. But I'm gonna get started here. See, that worked. All right, I'm not going to actually be talking about AI. The theme of tonight was supposed to be current trends, and definitely AI is the big trend everyone knows right now, right? But there is some other stuff happening in our industry besides that. Who here currently works at an organization practicing the practice of platform engineering, developer experience, developer productivity, any of these? Anyone? Got a few. Great. Who's heard of those things? Okay, there's definitely some awareness. For those of you who haven't, I don't put that much stock in these things, but the Gartner report, right, last year put platform engineering as like a major thing that people need to be looking at. So if you haven't heard of it, your CTO probably has, because they do pay attention to those things a lot, right? They're trying to identify what's up and coming next, what are organizations doing to become more efficient, move faster, and things like that. And it was called out there as providing a lot of value to companies. So my talk is just going to introduce you to the concept, where it came from, what it is, just so that now you can, raising your hand next time someone asks you, do you know what this is? I wanted to pick some kind of image there to put on my title slide. So I said, yes, the word platform, and this is Mario's got, or Donkey Kong has some platforms in it. But the more I thought of it, I think it makes sense. Mario or Jumpman, whatever like theory you subscribe to, is down there. He's your humble developer. You've got Donkey Kong up there throwing barrels down at you. That's I don't know who's that product. Throwing wrenches in your plans. And at the very top there, the place you're always trying to get to, the place where you want to be. At the end of the day, where you're always trying to strive for that, is production, of course. That is the princess up there. But a little bit about me. My name is John Burns. I'm a staff platform engineer at Grubhub. We're based here in Chicago, a Chicago homegrown startup, now a bit of a bigger company. I lead up development on all of the JVM ecosystem platform tooling. More about what that means as we go through. I also co-organize the Chicago Kotlin user group. And we meet roughly monthly. We kind of take a winter break because attendance is usually lower in the winter. But we're starting up again soon with monthly meetups where we have people coming in to talk about Kotlin, which if you're not too familiar with it, it's more than just Android development. There's a lot of back-end development happening in Kotlin now, especially here in Chicago. A lot of companies are doing that. And there's also even native development using Kotlin. So that kind of community has been booming these past like half decade or so. It's really taken off. It's a great community. So I encourage you to come join us. You can find us on meetup.com. I also am a maintainer of the KT-Link Gradle plugin. That is a Gradle plugin that links your Kotlin code. So I'm involved in open source as well. I've contributed to a lot of other repositories as well. You can find me on GitHub. You can find me on the Fediverse/Mastodon. And these slides are available on my GitHub, just as like a GitHub pages. So if you find me out there, you can get these slides. Yeah, just a quick thing about Grubhub, where I work. We have some perks. They're listed there. We're based in Chicago, like I said. If you
if you like what I'm talking about and you'd like to work at a place that does these things, you can come talk to me. We do have some positions open, not a lot right now, to be honest, but we have some. We do have some. Okay, so first, some history. In the beginning, there was development, right? And so developers wrote some code, and then they threw it over the wall to ops to run the code, right? And this had some problems. This was a lot of bottlenecks here, right? And so as an industry, we came together and said, let's put those together and make DevOps, right? This clears these bottlenecks that we had between development and ops, makes teams wholly responsible for owning their application from development to production. And this was great, right? This was really good. Platform engineering does not dispute how great DevOps is. It is just on top of it, because there are some still unsolved problems with DevOps. It raises a few new problems. It also doesn't solve every problem. So first of all, you have too much variety. So if you have a small team, maybe you have a couple dozen developers and you have a couple different teams and you're doing DevOps, that's probably going to be fine. But once you start getting bigger, a bigger organization, a middle-sized company where you have maybe a dozen teams, now every team is developing their own way of doing everything because they are responsible for doing it all themselves, right? So you end up between teams, things are done wildly differently, and that can cause confusion and chaos, right? You also have duplication of effort, right? So each team is responsible for this whole end-to-end, right? So that means every team needs an expert in CI pipelines. Every team needs an expert in Kubernetes or EC2 or whatever you're deploying to Azure, right? Okay. So you have a bunch of people now in your organization all solving the same problem and not necessarily sharing those solutions with the other teams. And what that boils down to is a lack of commodities, as I like to say. So a commodity here is something that should be just a given in your organization. I should be able to take a piece of code and deploy it to production, and that should not be a big deal, right? It shouldn't be something I have to, okay, well, let me figure out how this works now. It should be just a given, something that comes out of the box. The more of those you have, the more you can focus on the things that are actually unique to the problem at hand. So where the field of platform engineering started was trying to solve for these problems. And the field of platform engineering started a little over 10 years ago, I would put it. And a lot of companies started doing something called creating a DevOps team. Now, this sounds like an oxymoron, and it kind of is, right? Because the whole point of DevOps is your dev and your ops is one team, right? There's not a separate team. But it's a little bit of a misnomer. It's not actually like going backwards. It's what a DevOps team is to say, let's make a team that makes shared tooling that all of the other teams that are doing DevOps can utilize, right? Give them some stuff out of the box. It's not taking away the responsibility from those teams. It's just smoothing over the path. So they have some out of the box tooling to do what they need to do, but they still own their own process. However, just doing that wasn't enough, because the scope there of DevOps, it did solve problems, right? So now you have a DevOps team, right? They're going to build a standard like way of setting up your CI server so that you can just kind of plug into that and teams can just easily create their CI pipelines. Sure, and that's great. Once we clear that bottleneck, we quickly run into some more bottlenecks. Well, it turns out there's a lot more to developing and delivering and running software than just your CI and CD pipeline. That's a chunk of it, right? But DevOps teams tended to be scoped to that realm of things. So the first thing we had to do to add on top of DevOps is add scope. So a lot of the DevOps teams were staffed by kind of like traditionally like system engineers or like SRE types, people who are not necessarily very enmeshed in the, I guess I would say like the product production code ecosystems, right? So that they know Linux, they know Python systems programming languages, but maybe they don't know C# or Java or these kinds of things and all the tooling that goes around there. You're still kind of on your own as an application developer to know all of that stuff. So one way we can expand the scope from DevOps into platform engineering is actually thinking about, sure, we want to be language agnostic, right, in our platform, but what are our actual first-class languages and ecosystems that we're using, and let's build out some tooling, some turnkey tooling for those things. And specifically around builds here is like the first place where I would say is opportunity there, right? So sure, we have a standard way of doing CI and CD, but what about a standard way of just taking code and building a deployable unit out of it, right? What are we using Docker or what are we using to deploy? Let's make a standard way of doing that, because I can tell you that most developers have no interest in writing bespoke and maintaining bespoke build scripts to like take their code and build a Docker image out of it and do everything that you need to do to make it deployable in your organization. They're not interested in that. Most developers want to just write code and have it get deployed. Someone has to be interested in it, but you can centralize that function in a platform engineering team. You can also deliver platform services. So a good microservices platform is going to have some kind of API gateway, right? And maybe you use one out of the box in your cloud provider, or maybe not. Either way, someone has to write that, manage it. There's other tools. For example, in like the Spring Boot world, there's like a API gateway, like base thing that you can extend from, but you still like code on top of it to like customize it. So owning those platform level tools. So, I mean, other things that can fall in that bucket are like message buses or brokers, configuration servers, things of that nature. Finally, runtime libraries. So now you have this collection of platform services that you need to be able to interact with in a standard way, like you have a configuration server. Well, how do those configuration values get from the server into your application? Now you can deliver a standard library for doing that so that the microservice developers don't need to worry about actually making those calls to the configuration server themselves. So that's just an example of like the additional scope that we bring into when we talk about platform engineering. But I want to take a minute to stop talking about like solutions and think about what are our guiding principles? How do we decide what is a problem we should solve with platform engineering, and how do we decide how to solve those problems, or like in what way we solve them? So one of the most important ones is this idea of a golden path, not a golden cage, right? Or golden cage is also something like a walled garden, maybe, is another idiom that's similar to that. So what this means is we want to deliver a turnkey solution for our developers to deliver a product or service that works just out of the box. Like a new developer comes into the organization, they can hit the ground running and start delivering. However, we don't want to constrain you too much, right? We don't want to stifle innovation by saying, this is the one and only way you can do something here. So it's a balance, right? It's provide this turnkey way to get started, but leave the door open so that customization can occur if needed. I call it off-roading, right? If you want to go off the golden path, you can do that, but you're on your own, right? Like we're not, as a platform team, we're not responsible for making sure your custom thing works. That's your team's thing to own. So do it when you have a need to, like you have a need to make something custom because you have a unique problem you're trying to solve. Don't do it just for fun. And then as a platform team, we also have kind of a balance of carrot and stick, right? So there's sometimes we can build something into the platform that developers love to use. Wow, this is a great feature of the platform. I want to leverage this. It's going to make my life better. Yes, sure. I'll happily adopt this platform feature. That's great. That's what we want. That's what we try to build. We don't want to say, you have to use this thing because we said so, and that's the way it's done here. That is not going to make developers very happy. It's not going to make them very productive. And it's going to cause a lot of friction between people. So we try to rely on that carrot, not the stick. Sometimes you have to bring up the stick. You know, there's always going to be some people that think that they need to do something very crazy and different. And okay, but that should be the exception. We want to rely on the carrot. We want to build an actual product. Building a platform is building a product, and you want to satisfy your customers. So if you can get them to voluntarily adopt the platform, that is a sign that you're building something good. So here's how it's going now. So I'm going to break down what platform engineering looks like at Grubhub, so to speak. And this is not Grubhub specific, but this is how we have kind of drawn some lines. And it's just an example, right? Like every place doing platform engineering does it a little bit differently. I will say, you can read about Netflix, right? Uh-oh. I lost battery, I think. Dead battery. Let's see. Oh, there we go. Okay. So you can read about Netflix. They have a great engineering blog, and their model for platform engineering is basically what we followed at Grubhub. We're just less public about it, but you can read about their blog. I highly recommend it, how they approach platform engineering. But this is just an example of how you can think about what does a platform engineering department look like. You've got infrastructure platform. This is going to align closely to what we had in the DevOps team. So your infrastructure platform group might own CI tooling such as Jenkins, something like that. Continuous delivery tooling such as Kubernetes or Spinnaker or whatever you're using for deploying. Infrastructure as code solutions, your Terraforms, your Pulumis, things like that. They may manage those things. Of course, this is all about building self-service tooling, right? So they may own that solution, but it's still every individual team's job to contribute their service definitions and everything into these tools, right? It's still owned by the team delivering the service or product. They also might own some of the networking stuff that's happening, your load balancers, your edge routers, your CDNs, things like that. We see that as kind of infrastructure platform stuff. And then of course service mesh. If you're doing a service mesh, like Envoy or Istio, they're probably going to be involved in that. Service platform, that's where I work. Okay, so I talked about before, I'm in the Chicago Kotlin user group. I also am great friends with the Java user group folks. And so that's the JVM ecosystem is where I'm coming from. And so we use that to build our production services. So for that, in a service platform, you want to support those production services in the ecosystems where they are, it's specific to them. So that's build tooling is a big one. So whichever build tool you use, having some standard plugins or scripts for those build tools is really nice because, like I said, most developers never want to touch one of those in their entire life. Owning those platform services, right? They can be implemented in your primary language for your organization or one of your primary languages. So it makes sense for the service platform team to own those. Delivering runtime libraries, like I talked about before. And then here's service mesh again. Service mesh is this place where these two concerns kind of intersect, and there kind of has to be some shared ownership there because the way that you implement your service mesh is going to determine how these services interact with the service mesh. And so then that needs to be implemented in whatever your standard libraries are for that ecosystem, whether it's Java, Python, Node, whatever you're doing. So there's definitely crossover there with you're implementing a service mesh if that's something that you have. Okay, so that brings us to kind of what's next on the horizon. Because platform engineering is about building tools, right, to enable your product delivery teams to deliver products. But like I said, platform engineering has been going on for 10 years plus now. And so people are starting to see that there's an even bigger world out there beyond just building these platform tools. And platform engineering is a big part of a solution. Developers, right? And it's holistically thinking about what is it like to be a developer here at our organization. Having a great platform makes that experience a lot better. But there's some more to it than that. But first of all, I want to talk about this term IDP. Who has heard this term IDP before? There's a couple out there. Some people say it means internal developer portal, and some people say it means internal developer platform. So I just want to take a second to define what those terms mean. An internal development platform is everything I've been talking about so far. Okay, this is your internal platform at your organization for deploying applications. An internal developer portal is a UI for that platform. It is basically a single pane of glass, hopefully, ideally, where a developer can go to see everything that's going on in their platform. So that's tracking the deployment state of all of their services, like what versions are deployed in which environments or regions. It's also used, so that's like how it's used for like the actual service development teams, right? They're looking at their applications. They're looking at, sometimes it's even interactive. So like you can trigger a deploy from the portal. You can like look at all of your like build reports from the portal, like what is your code coverage looking like and all of those kinds of things. From the platform engineering side, we like this too, because it allows us to track things like adoption. So when we add a new feature to our platform, who has turned on that feature and who hasn't? We can track the adoption as it goes. Or as we deprecate things, who has turned off that thing so that like we can be sure that everyone stopped using it before we like rip the code out or whatever it is. Also, we can surface like security information through the portal. So tracking like what our vulnerabilities are on our Docker images and in our application dependencies, exposing that through the portal is really useful. So how this all kind of plays in, so how this like it plays into the developer experience is this is another principle that I would say is that we have at least is don't break the build. When we're developing the shared tooling, there's a big risk where we roll out a change. We roll out a new version of our Gradle plugins. We roll out a new version of one of our libraries, and it breaks somebody. It breaks their code. They can't compile, or it breaks one of their tests. And that's bad. That's a bad experience where you're just running the same code. You're checking out the same code that you committed yesterday, and now it's broken. And we try to avoid that at all costs. And so in order to avoid that, what we had to do is write a lot of instrumentation about which APIs our teams are using in our libraries, not just our libraries, but dependent libraries, like tracking usage of deprecated APIs in Spring, for example. All of these kinds of things we track, collect it at build time using our custom scripts, and report it to our portal to know who's using what, and we can do an analysis to say who is at risk of breaking if we make this change. And so that's what allows us to make what feels like a very stable platform that's not changing or breaking out from under you. But in reality, we're actually iterating our platform and moving it forward into the future faster than we've ever been able to do in the past. And that creates a great developer experience at the end of the day. You know, developers love it that like they never have to worry about their builds breaking out from under them, but yet they're still able to use the new things. We're able to use like JVM records in Java 17 now because we're able to modernize our stuff to be able to use Java 17, even though our stack was originally written in Java 8 back in the day. And so at the end of the day, this becomes a two-way continuous communication loop between the product delivery teams, the teams writing the services, and the platform engineering team. We communicate, yes, of course, through Slack and email and things like that. But the platform provides like a more like immediate and like real communication channel that's like not going to have any kind of miscommunication, because we are receiving from them information about what they're using, what their services are doing, and they're receiving information from us by us creating these like information radiator dashboards in the portal that tell them like, okay, here are the things we're tracking on your service. For example, what version of Spring are you on? What version of Java are you on? Which like instance types in like, we use AWS. So which instance types of AWS are you running on? Like, have you migrated to the newest generation or have you switched to Graviton yet? Things like that, things that we're tracking, we let them know and they can kind of get a report card of their services to let them know, do they have a lot of tech debt? Are they keeping up with modernization and things like that? And finally, I kind of hinted to this before. I was getting a little bit ahead of myself, but developer experience is more than just technical solutions. I've been talking a lot about technical solutions. That's what I work on mostly, but it's important to know that when you're talking about developer experience in that field, there's a lot more to it than just technical solutions. So first of all, if you want to learn more about platform engineering, I'm giving a more expanded version of this talk that gets a little bit more into details this year. I will be at DevNexus giving that talk and maybe some other conferences, we'll see. So you can watch out for that. But then, yes, so going back, what is there beyond technical solutions in terms of developer experience? There's some great research being done. One of the recent, it's actually a pre-publication paper that was put out recently by a great researcher named Kat Hicks. This is kind of a mouthful here, this report. Psychological affordances can provide a missing explanatory layer for why interventions to improve developer experience take hold or fail. Okay, but what this research is, it's talking about, and these are links if you go to my slides. It's talking about what processes in your organization contribute to a bad developer experience versus a good developer experience. And this is really important because there's a lot of research also coming out about how a good developer experience means better productivity from your engineers. And when you talk about engineer productivity, this is smelly, right? You get like flashbacks of people trying to count your lines of code or something like that, right? Most people understand that does not work, right? Trying to measure like empirically developer productivity with those kinds of metrics, it's not accurate and very easily gameable. Like everyone who knows what they're talking about with this stuff knows that's not going to work, right? So what this new wave of developer productivity stuff is talking about is, well, how about this? If we can show research that happy developers are productive developers. But there's a lot of evidence to back it up. So developer experience ties into that a lot. Making sure that the experience of being a developer is good in your organization, so you don't burn out your developers or make them disgruntled or things like that. So that's kind of how platform engineering plugs into this bigger goal of developer experience. Again, there's a link to my slides, and I think we're trying to wrap it up here soon. I know we're going to do the raffle drawing, but feel free if you have questions, just find me after this. So, thank you.
So I have been not cheating, but I've been drawing like 9 numbers now, and for these numbers, it's going to be the price of a book and a T-shirt. So gonna do it like this. I'm gonna say the numbers. Then you go to my nice colleague Maria, and she will give you a book and a T-shirt. We are limited